In the vast constellation of Orion, a crimson beacon burns brightly across the cold canvas of space. That beacon is Betelgeuse, one of the most colossal and luminous stars known to humanity. For centuries, its fiery presence has mesmerized stargazers and baffled astronomers, not only because of its enormous size and vivid red hue but now, because it's doing something completely unexpected. According to data recently captured by the James Webb Space Telescope, Betelgeuse has surged in brightness by a staggering 250%. This sudden transformation has reignited intense speculation. Is Betelgeuse preparing to explode in a supernova right before our eyes? Betelgeuse, classified as a red supergiant, is a massive stellar elder nearing the end of its life cycle. Situated around 642 light-years from Earth, it dwarfs our Sun in both scale and energy output. Imagine a sphere so vast that if it were placed at the center of our solar system, it would extend beyond the orbit of Jupiter. Radiating over 10,000 times more energy than the Sun and measuring roughly 700 times its diameter, Betelgeuse is the very definition of cosmic magnitude. But even in its volatile and unstable state, a 250% increase in luminosity is extraordinary. Thanks to the unprecedented sensitivity of JWST's infrared instruments, astronomers have been able to pierce the thick shrouds of dust and gas that cloak the star. What they saw was startling. In mere weeks, Betelgeuse's light output surged to unprecedented levels, revealing intense, dynamic processes occurring within. The change was so rapid and profound that some experts now wonder whether the end might come sooner than previously thought. Typically, stars like Betelgeuse exhibit erratic behavior in their final centuries or millennia. But until now, scientists had predicted that the supernova was still tens of thousands of years away. The recent brightness spike, however, cast that assumption into doubt. Could Betelgeuse be mere years or even months away from its final detonation? If it were to go supernova, the explosion would be visible in broad daylight and rival the full moon in brilliance during the night. Thankfully, Betelgeuse is distant enough that its death throes pose no threat to Earth. Rather, it would offer a spectacular, once-in-a-civilization opportunity to study a nearby supernova as it unfolds in real time. It could revolutionize our understanding of stellar evolution, explosion mechanics, and cosmic chemistry. To comprehend what might be happening inside Betelgeuse, scientists are examining several potential causes for the sudden brightening. One of the most compelling theories involves convective plumes, gigantic bubbles of superheated gas rising from deep within the star's interior. Think of it like boiling water, but on a scale where the bubbles are the size of entire planets. These turbulent convective cells can carry immense amounts of energy toward the surface, disturbing the star's equilibrium and causing layers of gas to bulge outward or even rupture. If such a plume breached the outer layers of Betelgeuse, it could lead to a temporary elevation in surface temperature or a rearrangement of heat distribution across the stellar surface, both of which might manifest as a dramatic surge in visible brightness. In extreme cases, this convective violence might even expel material into space, stripping away cooler surface layers and revealing the hotter interior. Without the usual veil of dust and gas, Betelgeuse would shine with greater intensity, which may be exactly what astronomers are witnessing now. Another plausible explanation is a stellar eruption, a titanic outburst in which the star violently ejects massive volumes of gas and dust. This kind of event could be triggered by intense magnetic fields, sudden changes in internal pressure, or catastrophic energy releases near the core. For Betelgeuse, such an eruption could resemble a solar flare, but amplified 1 trillion times. If this occurred recently, the expanding shell of debris could be reflecting more of Betelgeuse's light back to Earth, enhancing its brightness in a kind of cosmic feedback loop. This would not be the first time Betelgeuse demonstrated mysterious behavior. Back in late 2019, the star dimmed drastically, alarming astronomers and prompting a surge of studies. That dimming was eventually attributed to a large dust cloud that temporarily blocked some of the star's light. The current brightening might be the aftermath of that event. Newly expelled material could now be acting as a reflective surface, bouncing light toward us and artificially boosting its apparent luminosity. Still, this explanation does not exclude deeper changes. Some scientists argue that Betelgeuse may be undergoing significant structural shifts in its core, possibly driven by a new stage of nuclear fusion. As stars exhaust their hydrogen, they begin fusing heavier elements like helium, carbon, and oxygen. Each stage releases different amounts of energy and affects the star's structure in unique ways. It's possible that Betelgeuse is transitioning between fusion cycles, and that this phase shift is manifesting as a chaotic increase in light and temperature. These developments are more than just academic. By closely observing Betelgeuse, astronomers are refining models of how massive stars evolve and die. Red supergiants are among the most difficult stellar objects to model due to their size, opacity, and variability. Yet understanding them is crucial for unraveling the life cycle of matter in the universe. When such stars explode, they distribute elements like carbon, oxygen, and iron into space, materials that eventually form new stars, planets, and even living beings. What's more, these cataclysmic events are responsible for seeding the galaxy with the building blocks of life itself. The very iron in our blood and the calcium in our bones were forged in ancient stellar furnaces like Betelgeuse. In a way, studying its decline is like tracing the origin story of everything we know. Each spectral shift, every photon of light it emits, carries whispers of the universe's past and the fate of its future. As the astronomy community ramps up efforts to monitor Betelgeuse, new telescopic campaigns are being coordinated. Instruments across the globe, from radio observatories in Chile to optical telescopes in Hawaii, are collecting data to track the star's every flicker. Machine learning algorithms are even being applied to parse the vast influx of observations, hoping to identify patterns that human eyes might miss. The public, too, is captivated. Social media threads light up with each new update. Amateur astronomers point their backyard telescopes at Orion, hoping to catch a glimpse of history in the making. Educational programs and science centers are using Betelgeuse to teach about stellar life cycles and the vastness of space. It has become a symbol, not just of death, but of celestial transformation. So we watch and we wait. Perhaps Betelgeuse still has centuries to go before its final blaze. Or perhaps the countdown has already begun. Regardless, its story continues to unfold before us in real time, a cosmic drama playing out on the grandest stage imaginable. With every night it shines, Betelgeuse invites us to bear witness, to look up, to wonder, and to remember that even in endings, the universe writes its most awe-inspiring tales. The magnetic field of Betelgeuse remains one of the most mysterious and least understood aspects of its complex structure. While it radiates like a beacon in the Orion constellation, scientists are beginning to suspect that magnetic fluctuations deep within the star might play a critical role in shaping how energy escapes its surface. These unseen forces could be rearranging the flow of charged particles, subtly redirecting the star's energy through chaotic twists and violent eddies. In moments of sudden brightness, those surprising surges that have baffled observers, some researchers believe these magnetic forces may be the culprits. If this idea gains proof, it won't just adjust a few models on paper. It would fundamentally alter our understanding of how magnetism drives the life cycles of the universe's most massive stars. It would open a new dimension of stellar astrophysics, one where magnetic storms raging across titanic surfaces rival even gravity in their influence. Yet for now, it's an area of science that remains in its infancy, largely due to the incredible difficulty in observing such phenomena across cosmic distances. Even as attention sharpens on Betelgeuse's magnetic mysteries, astronomers are equally focused on another dramatic aspect: its mass loss. Red supergiants like Betelgeuse are infamous for their chaotic shedding of material, vast rivers of gas and billows of dust escaping from their bloated atmospheres like breath from a sleeping giant. This mass loss is more than a cosmetic change. It actively reshapes the star's outer layers, cools its surface, and alters how the star pulses and glows. Every gust of stellar wind strips away more of Betelgeuse's envelope, potentially nudging it closer to collapse. An uptick in this mass ejection rate could be a critical red flag, a whispered warning that the end is near. What makes the timing of all this so remarkable is that it's happening just as humanity has deployed one of its most advanced scientific tools, the James Webb Space Telescope. Its mirrors, floating a million miles from Earth, are finely tuned to detect the faintest signals through clouds of cosmic dust that would blind other instruments. It can dissect starlight into its atomic ingredients, revealing a star's temperature, its chemical soup, even the convective churn of matter beneath its surface. That makes Betelgeuse in its current state not just interesting, but irresistible. With the star growing brighter and more unstable, many are beginning to whisper the possibility of a true cosmic finale. The idea that we might be watching the final days, or decades, of Betelgeuse feels like something out of myth. But astronomers urge caution. Red supergiants are notoriously volatile and can go through long periods of violent activity without proceeding to the ultimate endgame of a supernova. This could be another flare-up, albeit more intense than usual, a kind of celestial tantrum rather than a death rattle. And yet, the numbers tell their own story. A 250% increase in brightness within such a narrow window of time is not a minor fluctuation. It's an explosion of energy that demands explanation. Something within Betelgeuse is roaring with intensity, and even if that something isn't the end, it is undeniably dramatic. What's unfolding in Orion's shoulder is a visceral reminder that space is not still. The stars we see in our night sky are not statues. They are living, evolving entities filled with tension and movement. What truly excites the scientific community is what lies ahead. With the James Webb Space Telescope fixed on Betelgeuse, and Earth-based observatories across the globe joining in, we are gathering an unprecedented stream of data. Every wobble, every flicker, every hint of turbulence is being recorded. The Hubble Space Telescope is capturing ultraviolet signatures, while Chile's Very Large Telescope peers deep in the infrared. Radio observatories listen for strange pulses. Together, these instruments are building a day-by-day chronicle of Betelgeuse's moods, a stellar diary that could, for the first time, let us piece together the real-time death of a massive star. It's a treasure trove not just for those studying Betelgeuse, but for the entire family of red supergiants. The data collected here may ripple through decades of research, helping astronomers decode other mysterious giants scattered across the galaxy. And if the star does explode within our lifetimes, it would be nothing short of a historic spectacle. The death of Betelgeuse would not just light up the sky, it would light up the imagination. The event, known as a core collapse supernova, is among the most powerful known in nature. It starts when the star, having burned through lighter elements like hydrogen and helium, begins fusing heavier ones, carbon, oxygen, and eventually iron. That's the point of no return. Iron fusion consumes energy rather than releasing it, and once it begins, the internal pressure that holds the star up against gravity vanishes. In an instant, the core collapses, crushing atoms into neutrons and triggering a shockwave that rips the star apart. From the outside, it would appear like a slow blink, a brightening over days until it outshines every other star in the sky, perhaps even rivaling the full moon. It would cast shadows at night, visible from cities and countrysides alike. Despite its proximity in cosmic terms, just over 600 light-years away, the explosion poses no threat to Earth. There's not enough radiation to affect us. But scientifically it would be a gift. Instruments could observe the entire process from start to finish. For the first time in history, we would have a clear view of what happens during a supernova's initial moments, through its expansion, and into the formation of the remnant core, either a neutron star or a black hole. Astronomers would also be able to study the ejecta, the vast clouds of gas and elements hurled into space. That debris carries the seeds of future worlds. It's how the universe recycles. Supernovae create the very elements we depend on. Oxygen for breathing, carbon for life, iron for blood, silicon for stone. In a very real sense, we are stardust, assembled from the remnants of long-dead giants. The explosion of Betelgeuse wouldn't just be an ending. It would be a beginning, the start of a new generation of stars and possibly planets. The shockwaves might trigger the collapse of nearby gas clouds, igniting fresh star formation. These newborn stars could carry traces of Betelgeuse's final breath, its signature imprinted in their light. To witness such an event would be to watch the universe reweaving itself, tearing apart the old to make room for the new. It's this cycle of death and renewal that drives galaxies forward, populating the cosmos with fresh stars, rich chemistry, and new possibilities. Public fascination with Betelgeuse has exploded alongside its brightness. What was once an obscure astronomical subject is now a headline-grabbing phenomenon. Social media has turned it into a star of its own kind, with countless posts speculating about when it will go. Videos, animations, live streams, and simulations now circulate widely, drawing in people who may never have looked up at Orion before. But now they do, curious, hopeful, maybe even a little anxious. It's rare that an event this grand feels so close. You can walk outside, tilt your head, and point directly at a star that could any day light the heavens like a torch. That immediacy sparks something ancient within us, an echo of the awe that our ancestors must have felt, staring at the same spot in the sky, wondering what it meant. For millennia, humans have gazed upward in search of guidance, beauty, and understanding. The stars were calendars, compasses, stories. Now they are data, equations, and still, somehow, wonders. Betelgeuse occupies all those roles at once. It is ancient and modern, predictable yet wild, close enough to study and yet far enough to remind us of our place in the vast machinery of space. Whether it explodes tomorrow or a century from now, it has already left a mark. It's become a teacher, a messenger, a cosmic alarm clock ticking loudly in the night. Its strange behavior has reignited the spirit of observation. Telescopes once pointed elsewhere now pivot back to this fiery beast. Scientists revise models, students run simulations, Even poets are stirred by the possibility of watching a sun die in real time. And so, with eyes locked on that ruddy point of light, humanity waits. Waits for more brightness. For a dimming. For a signal. For the spectacular unknown. Betelgeuse pulses not just in space but in our imagination now. It is no longer just a star, it's a story unfolding, a chapter of the universe being written before us in waves of light and bursts of matter. Whatever happens next, its legacy is secure, etched in data, in science, and in the stardust that binds us all.